Cool. Hello, everyone. Welcome to our project demo for the course CS291A. This course is offered at UCSB on mixed and augmented reality, and so this is done by me. My name is Shubham, and I also have my friend Satyam here with me.
Hi.
Uh, Hello. And so we are first going to give a short demo of what what is this whole system that we have tried to develop in virtual reality, and we're also going to demo all the different features that you can do and like that you can play around with. And then later we will dive into the technology details and the architecture details of how we have actually developed the entire backend system. So let's get started. So before we proceed further, so these are the two GitHub repos. This repo on spell training in VR is all about it gives us it contains all the assets and all the packages that we used in building the virtual reality game. And this repo on virtual board has all the image recognition module packages that we've used to build the game. So
And both of them are public, I guess, so you guys can recreate this game on your side if you want to.
correct. And the links for both these games are like in the very end of the document right over here. So yeah, feel free to fork and add more features and like raise pull requests. So yeah, so the very first thing that you need to do before you start the game is, okay, I need to turn off my camera because right now I'm only dealing with I only have one single camera source, and for playing the game, you're expected to have at least one camera with you. So yeah, actually I'll also hide the video panel and the floating meeting controls. So the very first thing that you need to do before when you start the game is run this server.py file. Right now I'm using PyCharm. I've used PyCharm for developing the whole image recognition module. Cool. So let's run it. Yeah, cool. So this is up and running. Once you have your server on the Python side running, then you can go back to your Unity game and start running the game. We'll properly explain why we're doing what we're doing, and like why do you need to start both these servers. And we'll dive into the technical details. But for now, let's just try to understand what is it that we have built. So Satyam, feel free to like jump in and like add more
Yeah,
to this
yeah,
whole thing.
sure. So as you can see in this virtual world, uh, the user can move around and freely look around.
Yeah.
Yeah, so he
So
can move around, and implementing this required a few minor adjustments. Like we always need to check if this guy, the player, is close to the ground or not, because that helps in jumping. So if you can jump,
oh,
yeah, so
yeah.
he can just jump one times and not multiple times. That's what is grounded checks for if you're close to ground. And yeah, you can move around as you can see. And the other thing is that you can look around, and uh, that also required a little bit of work, because you need to have your cursor locked to the center of the screen, and which is what we are seeing over here. And and there are just a few UI components which I modified. Like there's a crosshair in the center of the screen, and this will be used, and we'll see why it is important in the later stages. So Shubham.
Yeah, cool. So now that we've seen how the virtual world is, let's try to see what you can do. Okay. So you just need to point this crosshair in the direction where you want to, summon new creatures or create new creatures. So we are going to, for the purpose of this video, we are going to use the word creature and monster interchangeably. So
Yeah, yeah. Actually, that's our whole idea, that uh, you are some person who is there in the magical world of probably Hogsworth. We have not
yeah,
decided that yet,
yeah,
and that's why the whole aura and atmosphere of the game is like a
yeah,
fantasy medieval type of
yeah.
atmosphere.
So yeah, if you ever wish to be Harry Potter, this is your chance.
This is
So now I'm gonna uh, click the left button on my mouse, and this will initiate a fire action. And yeah, here you see me again. So this is where the whole game starts, or like the whole interaction system starts. The moment you fire, you see yourself. Like we initiate a system called picture in picture mode, where you can see yourself. And now we the basic goal is that we want to interact with this virtual world, and we wanted to do that using hand gestures and posture recognition. So we have used a library by Google, MediaPipe Hands. It's a very popular library. Okay, we had a small glitch, so we'll have to restart the server. Okay, cool. And I'll have to fire the wand again. Cool, we are back. So I'll try drawing some gesture. Okay, so I draw a 2, and here we have our first monster or creature developed. If you go close to it, you can also listen to the creepy sound that this monster has.
I think we can't hear that. Maybe your
Oh, you
volume's down.
oh, my volume is down. That's why. No, I think that's not the problem. I think when you record, you can't record the volume or
Yeah,
like
from
the
the app.
sound from the app. So, but yeah, when you run the game, yeah, you can listen to it. So let's try creating more monsters, and let's try to play around, and let's see what are the different types of monsters that you can create. So I draw a 4 here. Oh yeah, one more important thing is you can't draw any gesture, any random gesture. Uh, we are strictly sticking to numerals from 0 to 9 for the purpose of the game. So that, I mean, you can draw a random gesture, and we'll try to find the closest fit to these numbers. That's the whole idea. So
But it will again match it to the digit which it is closest to.
closest to, correct. Yeah, yeah. So let's try to draw a 5 now. So you can see that wherever I place my crosshair, at exactly the same point, the monster is created. This monster is my personal favorite. It's the Spectre. It's very deadly. So let's try summoning or creating another new monster. Let's draw a 7 this time. So as you can see, when we draw different numeral digits or different gestures, there are different types of monsters that are created. So these monsters are unique to the number that you're trying to draw. And this process of drawing is what we're calling as mid-air sketching, because I'm literally sketching in the middle of the air, and I'm using the camera on my Mac to track what I'm actually drawing. So let's draw one more monster, and then we'll move to the next aspect of the game. So let's draw a 9. And yeah, here we go. Here we have another new monster. Let's try to take a closer look at it.
That's a lizard guy.
Yeah. So now that you've created different monsters, we thought we should do something more here, right? I mean, this is fun. This is where uh, since so you can imagine that this is some sort of school where you're taught to draw gestures, okay, like that they do in Hogwarts, right? Where you're taught to learn spells and like learn gestures to summon new creatures and do things. So we thought, let's add another interesting aspect to it. So when you point at a monster and try to fire, so I point at this particular monster and I fire. So we wanted to see that, can we manipulate this monster in some way? So for instance, if I draw a 2, this should ideally destroy the monster like it did. Okay. And let's play with this guy over here. I'll try to draw a 5. And okay, let's try and draw a, oops, again the server broke. There's some issue with
I
it, but
think this issue like happens sometimes and depends on your operating system, because it's all socket
Oh,
communication and managed by the OS side. So hopefully
okay.
there is a fix for that.
5. So I draw a 5. So when you draw a 5, you can scale the monster, and you can
Yeah.
I can again draw a 5, and we can rescale it even further. And I again draw a 5, and oops. Oh, so what happened here was that I was trying to scale the monster, but it did not hit specifically in the right direction, and that's why I thought that I'm trying to summon a new monster. So you have to be very careful with where you place your crosshair while summoning these new creatures. In a way, you have to learn how to cast spells. You can't just wave anywhere and like try to do what you want. Let's try to do something else. Let's try to. I'll try to draw 8 and point at this particular monster here over here. And again, this has been scaled. Let's try to play with this guy over here. Let's try to play with Spectre. I'll draw a 9. When I draw a 9, let's say what happens. Yeah, here with this particular gesture, we transform the creature or monster into something else, like they do in Harry Potter, right? Where there are specific spells where you can convert humans to creatures and creatures to humans and whatnot. Something similar. Let's try to see what happens when I draw a 0 for this particular monster. And when I try to draw a 0, ideally its position
It's
must be
teleported to somewhere else.
to somewhere else, but you have to go and find where it's teleported. Okay, so that's another game. That's another fun aspect of the game, that you have to go around and see where it got teleported. Yeah, so I think Satyam, do you want to add more, or like, do you think this is enough
So
for
yeah,
the
I think you covered all of the features quite well. Yeah, we can move on to the description of the technologies.
cool? Okay, and okay, so let's go back to our Google document. So we have created this Google Doc. We are going to make it public, and anyone can go and like look at this. And we wanted this to be as descriptive as possible, so it's super long. It's around it's 17 pages long. But the idea is that if one wants to go and start making changes to the game, he can just read the document, and that should give the person a good idea of the
Yeah,
whole
so you
thing.
have the instructions there with you.
Correct. Yeah. So yeah, I'm just trying to turn on my video so that, oops, show video panel and hide floating meeting controls. Cool. So I think I don't need to go through the overview. Like, we have tried to build an interaction system where you manipulate things in the virtual world with gesture recognition. I'll quickly talk about the different technologies that we've used. Uh, so we have used OpenCV, the whole image recognition thing that you saw in the game. That was that was developed using OpenCV in Python. The whole virtual world was developed using Unity, and like if you did notice while we were running the game, it was a Unity software that we were trying to play around with. The whole hand gesture tracking and finger tracking and hand landmark prediction part was taken care by the MediaPipe hands library. Uh, it was developed by Google, and like it's freely available. You don't need to pay anything for it. And the part of recognizing what we've drawn was taken care by Tesseract OCR. Tesseract OCR was initially developed by HP, but now again Google is taking care of it. So now let's quickly dive into the most interesting aspect of the whole system that we've developed, like the whole design of the game. So I'll let Satyam talk more about this.
Yeah, so as you can tell that we are running a script separately for in the Python, which takes care of all the image processing part. And then there is the Unity app side, which is just the virtual world. And both of them like talk to each other. And so this way we have dedicated all the image processing to a server side and the player and the game to the Unity side. So this way we didn't need to like buy some different assets or packages to make OpenCV run in the Unity. And though it is glitchy as you saw, but it works and was quite like manageable to develop the game this way. So
Yeah.
there are a lot of different uh, components of this game within the Unity module and the OpenCV module. So I think we
Oh yeah.
can just go on and discuss them later.
Okay. Yeah. Yeah. So let's discuss about these different modules as we progress further in this recording and presentation. So so the picture-in-picture mode was something new that we tried to do. I don't know if anyone has done this before, so I think we should
So
talk more
let
about this
me,
part.
yeah.
Yeah.
So the inspiration for picture-in-picture mode came because uh, when we showcased our project to our professor, he gave actually the idea that because we were dealing with two separate windows, there we were running a game window, which is the Unity game application, and then we also had to make OpenCV window open, and so you have to switch between both of those two like but
Yeah.
like when you're drawing, you have to draw on the OpenCV window your gestures and then come back to the Unity window to see what happened. And obviously this wasn't the perfect solution and the interaction was not as seamless, so we had to develop make a sir gave us idea to make the window over there at OpenCV to like appear at one corner, and that's how you can have a picture-in-picture type of interaction with both of the modules. So, so
Correct.
how we make that possible is that uh, as the game starts, the Unity side, so it boots up a C# server 2, and it keeps on listening for messages from the Python client. So, so yeah, when the user clicks, he shoots and it starts up the Python server, and the Python, it does all its image recognition stuff. And while it's doing that, it keeps on relaying back all these frames which you see to the client, and the client gives it back to the C# server. And C# server will do all the image decoding because image sent is a byte stream. It decodes that and applies it on the that UI component on the corner, which you see, that little PIP frame, and that's how you see it. And once this process completes, when we receive the answer from the Python server, the C# client now this time, it will end this PIP mode, and that little window of you, the mini size of version of you, it will disappear.
Yeah. So this is not going to stay there forever. Once the recognition module is complete, we ensure that we just turn it off and like it disappears from the UI component. That way, the whole transition remains seamless, as Sachin suggested.
Yeah.
Cool. So yeah. So this is how the whole uh, module of the picture-in-picture is taken care of. I think I don't know if someone has done this before where they've tried to marry the Unity system with the OpenCV system, but yeah, this was really interesting, and this was where we spent a lot of our time on.
Yeah, we faced a few issues. The major bottleneck was because Unity API only supports single-threaded work,
Yeah,
so we have to take care of that. If you like try to summon a different thread and work on that and try to contact on the main thread, yeah, you will get errors because Unity isn't allowed multi-thread workflow.
yeah, yeah. You can take a look at the code and try to see like how we have taken care of it, and like we'll leave that to the users because we don't want this video to be super long. Cool. So now let's take a quick look at the image recognition model. This is where a lot of fun happens. As I already discussed briefly, like we use the MediaPipe hands API library, which is again developed by Google. By the way, MediaPipe is like an entire suite of libraries. So MediaPipe hands is just one segment of MediaPipe. MediaPipe also has face recognition modules, posture recognition modules, and like whatnot. Like you can check out the links in the document, and like you can use MediaPipe for n number of image recognition tasks. So for here, our we specifically wanted to interact with the virtual world using gestures. So it made sense to stick to MediaPipe hands. And yeah, so these are some of the results. Like even if you twist your hand, even if even if you uh, move your hand in different directions along different angles, it does a fairly good job of identifying hand landmarks. So this part is extremely important. It gives you a list of 21 hand landmarks on the image that you're trying to play with. And so what we thought was like, let's fix one particular hand landmark position. So this landmark number 8 is nothing but the tip of your index finger. And we thought, why not just focus on the trajectory of this landmark point 8 and use that as a paintbrush for drawing midair. So as I move my hand, if I'm able to track the position of this particular landmark on my index tip, I can use it as a brush and like just draw around. So that was the idea of using MediaPipe hands, and it was extremely useful. So once we did that, we came up with different heuristics. So again, as Satyam already suggested, with the picture in the whole idea of using developing the picture in picture mode was so that the user doesn't have to toggle in between OpenCV window and the Unity window. And we just understood here that how would we draw gestures. But once you're done drawing the gestures, you need to tell OpenCV that yeah, that my drawing is complete and that now you're supposed to recognize it. So we thought, let's come up with different gestures, and for that we use different heuristics. For instance, we developed a heuristic called fingers up, which means that if the y coordinate of landmark 8 is greater than y coordinate of landmark 7 and 6, then that means most probably your index finger is upright. Similarly, if the y coordinate of index 12 is index point 12 is greater than 11 and 10, then most probably your middle finger is up. And like you can use it and expand it for all the fingers. And this was just one simple heuristic that we came up with. We are not claiming it to be super rigid, but it serves the purpose and like it works mostly without any issues. So these are the 4 different important postures that you need to learn in order to play the game. The first is the selection mode, where you have your 2 fingers up. In this particular module, you can just select different aspects on the OpenCV window. I'll quickly have to go back to explain this better. So with the picture in picture mode, you can draw, and if you see these tiny icons on the top, so that it's basically a panel where you can use this particular icon to erase what you've drawn. You can select this particular icon to draw whatever you want, and you can finally use this third icon here to recognize what you've drawn. So in order to select these particular icons, you can use this posture where your first 2 fingers are straight up. The second posture is very simple, like you can just use it to draw. The third posture is all your fingers are up. We decided to come up with this module because we realized, like, while you're drawing, it could be very difficult in the beginning to draw. Like we have done it multiple times, so it's easier for us. And sometimes you might want to erase the entire canvas, and you can't just use your eraser to like erase everything that you've drawn. So you can just raise all your fingers up, and that will just clear the whole canvas. And then since we both are like Spider-Man fans, we thought, let's come up with this posture, which the Spidey posture, let's call it the Spidey posture, which basically tells the OpenCV server to not the OpenCV server, my bad, like the OpenCV backend to go and recognize what you've drawn. So yeah, more about this in the further presentation. Like so here I'll quickly try to understand, like make you guys understand like how are we actually trying to draw things. So with OpenCV, you can just start your camera and like you can look at yourself the way I'm looking here. And with MediaPipe hands, you can track the location of your index finger. And as you move your finger around, what you could do is you could initialize a new plane, a simple, this is nothing but a simple XY 2-dimensional matrix having all values 0, and that's why the image is black. And as you move around, you can track the location and you can keep coloring every pixel as the index finger moves. So this way, what is it that you've drawn. Like it's super easy. Now the only challenge is to add these two, and it's super easy. It is not difficult at all. You simply take a inverse of this image where this black part becomes white and this this pink thing becomes black, and then you take an AND operation with this image, and then you add this image back to the original image, and that's it, and that's how you generate it. It isn't computationally expensive. You might feel that there must be a lag, but as you already saw, there's no lag. Like, and this is absolutely very fast, especially if you have a good processor. And then let's quickly talk about how we recognize things, right? So let's say you've drawn this two, and we already said, right, that whatever you draw, that is drawn on a different plane. It's drawn on a different matrix. So we also have the matrix. Now we simply extract the contour of what we have drawn using very simple image processing algorithm. This is not difficult at all. And like we extract a simple two, and then we use the Tesseract OCR library to recognize what you've drawn. And like here is the code snippet for extracting the contour. And yeah, this is not rocket science. This is super easy. And like you can go back to the GitHub repo and like take more looks into take more dive into the details basically. So I'll let Satyam speak about how the virtual world was developed. Like all this was about the image recognition module. Now let's shift gears and let's try to understand how the whole Unity virtual world was developed. So over to you, Satyam.
Yeah, thanks, Shubham. So I'll just go through it quickly. So the environment, as I told before, we tried to create match the theme of the game. So like somewhere like Harry Potter world, and so all has all those elements like barrels, huts, and church to be give a medieval fantasy atmosphere. And yeah, so the different components in our Unity game would be first of all the main camera, and camera, apart from providing the first person view to the user, would also contain we have attached the wand to it so that it's always in the view of the user. And as we saw, wand serves a lot of purpose, like summoning the creature and also activating a lot of special effects like particle system effects. And next we have the canvas. So canvas is where all the UI elements should be. And the first and foremost, the most important UI element is our picture-in-picture frame. And it only is enabled when the user activates the spell casting mode. Next is the crosshair, which is enabled throughout. You can always see that there is an orange dot in the center of the screen, so you know where you have casted the spell. Next, there is the Unity Raycast. So this is more of a special function provided by Unity. So would you like to say about it, Shubham?
Yeah. So like this is super simple. So like this green line is not what you actually see in the game. Like we just extrapolated a line along the direction of the wand. And what it does is Unity Raycast is it's like a Unity module which helps you, which gives you information where is this physics raycast. What is the point of collision of the physics raycast? For instance, like here the wand is hitting this particular house, so it will give you the XYZ coordinates of the point, and it will also give you information about the game object that it is hitting. So this house here is a game object in itself, and it will also give you what is the name of that game object and what is the location of the game object, and then you can do all the fun stuff. So that is how we track what is the monster that we are trying to hit. If there's a monster already in the game, and if there's no monster in the game, then we just simply pick the XYZ coordinate and do something with it. So yeah, and quickly talking about the game monsters, like the monsters in the game, like these are the different objects, and these are again game objects. Everything in Unity is game objects. Mostly it's game objects, and if you have some background in data structures, you can manipulate these game objects using very simple operations.
So
So
specifically,
mhm,
these are prefabs. So whenever
yeah,
you want to make change to one of them, it would be reflected to most of them, all of them,
correct,
sorry.
correct. Yeah,
And so it's like more efficient that way. Right.
yeah, yeah. Cool. So this is the code snippet of how we spawn a new monster. You can take a look at it. I'll let Satyam talk about particle system because this is what gives the
Yeah,
cool
yeah.
effect to
So
these to the wand.
first, let me tell you where you did see the particle system in our game. It was at the wand. There was a burning fire effect there on the wand. Yeah, like this one. And whenever you shoot, then there is like a lightning jolt, and then whenever it falls at a place, there are kind of bubbles or cloudy effects bursting out of that place. And whenever a monster dies, that's also a particle system. So like it's provided by Unity, and it's how you can simulate different type of effects like liquids, smokes, clouds, flames, whatever you have. And like it's like quite convenient to have those effects in your game. Yeah.
Yeah, yeah, cool. So let's quickly talk about some special effects. Special effects relate to what you can do with existing monsters. So in very simple terms, when you fire a wand, you know where it's gonna hit. So we check if the point that you're trying to hit, we calculate its distance from the center of the existing monsters. In fact, all the monsters, and see that if this distance is less than a certain tolerance, you can set the tolerance. It's very like you can do it within Unity itself. And if that distance is less than tolerance, then you do something to the monster. Like as we already saw, you can scale the monster, you can teleport it, you can change it into another monster and whatnot. Like you can go and add your own custom manipulations. So yeah, so this is the code snippet for it, and I'll quickly go through the uh, flow flow diagram for whatever we discussed. So initially, the whole Unity game waits for the user to fire his wand. Once the user fires their wand, we cast a new physics raycast game object, and then we check if the raycast hit point is close to one of the initiated creatures. Right? We check if the distance is less than tolerance or not. If it is less than the tolerance, then we recognize what is the gesture, like whether it's a 2 or a 3, and then we manipulate the monster based on what we have recognized. But if the distance is greater than the tolerance, and if the recast hit point is farther than all the monsters that you have summoned so far, then we again recognize the gesture and then spawn a new creature based on that. And then we flash the particle system like like those white bubbles that you saw in the air, like which give it a magical effect. And then we repeat again, and then we go back to the initial state, and like this whole process keeps repeating that. It this gives you a good overall idea of how the flow is. Cool. So yeah, that's mostly what we wanted to talk about. I'll let Satyam quickly talk about the user feedback and like
Yeah,
conclusion
yeah.
and the
So
future
to
work.
evaluate how well our interaction system works inside the game and how we are like able to utilize it, we asked like 10 of the past participants to give their views on it, and we asked them questions like how natural it felt to use this system of drawing out gestures and then having it to serve some purpose. Second, we asked, uh, did these commands always work on the creature? Next, we asked, do they require a lot of learning time to like flawlessly use this system? Finally, we asked if they did face any lag. So the scores look quite good for us. As you can see, this PIP mode felt natural to them because of a high 9 score by average score for them. Similarly, the commands always seem to work. So the algorithm was correct, I guess. And then the learning time needed was also quite low, as predicted by said by the low score. Finally, the lags and issues, as you saw that there are some glitches due to the socket communication, and which is due to the operating system side, uh, which we, I guess, don't have much control on. And finally, the overall experience was a very high 9, and we are
Yeah,
happy to see that.
cool.
So, and in addition to that, we also asked that if they'd like to see some extra features being added to the game. And it was quite enlightening to hear their views, because they had a good like amazing feedback. Like one of those feedback was to maybe add AI to those monsters and using OpenAI or GPT-3, so it would be like even more immersive for us. And then maybe make the game multiplayer, and maybe instead of using a PIP mode in which you have to show the user on the screen, game screen, you just start the take the OpenCV data and move the wand inside that game, just the XY coordinates of it, and it would be seamless as well. But we can try that too. Okay. And
Cool.
then, yeah.
Yeah, that's mostly what we wanted to talk about. And cool. Hope you liked what we presented. Have fun. Have fun playing the game.